Welcome to qnawire.
The first step is to formulate the hypotheses. The null hypothesis is that the observed frequencies match the expected frequencies based on the guide's reported percentages. And that would be the first choice. So I'm going to stick with that. I agree that it should be A. And then the alternative is at least one does not. Okay, so then the expected frequencies need to be calculated in order to calculate the chi-squared statistic. So the expected frequency for one number would be 970 times 0.51. For 2 would be 970 times 0.32. For 3, it would be 970 times 0.14. For 4, it would be 970 times 3% or 0.03. Let me calculate those all real quick. We got 494.7, 310.4, 135.8, and 29.1. And now the chi-squared statistic is the sum of the observed data minus the expected squared over the expected. And that would be 476 minus the expected 494.7 squared over 494.7 plus, for 2, and it was actually 342, so 342 minus the expected 310.4 squared over 310.4 plus, for 3 would be 113 minus the expected 135.8 squared over 135.8 plus, for 4 was 39, the expected was 29.1. And so our chi-square statistic calculates to, let me get this into a calculator. $11.12, and now we need to find the critical value, and so this is with significance of 0.01, and degrees of freedom would be the number of categories, which is 4 minus 1, so the degrees of freedom is 3. The chi-square critical is we look at the upper 12.8382, and it does not exceed that, so it doesn't fall within the rejection region, so we would fail to reject the null hypothesis. So go 12.83 for the chi-squared statistic. We can go to a p-value as well. P-value from a chi-square score of 12.83. Oh, 11.12, I mean. With 3 degrees of freedom at the 0.01 significance, we would fail because the p-value is 0.011. To 4 decimal places, 0.0111. And again, we would fail to reject the null hypothesis. There is insufficient evidence, so that would be choice D.